Okay, this is the notes we took on trig, so sine, cosine, and tangent in class on Tuesday, February 26th and Wednesday, February 27th. Okay. So the first function we have is the sine function. So we are going to input a angle measure, and output that function is going to give us is a ratio. Okay, that ratio is going to be of the opposite side over the hypotenuse. So here's our angle theta. We take the sine of theta, right? It's going to be equal to the opposite side over the hypotenuse. The opposite side is across from the angle we're talking about. And the hypotenuse is across from the right angle. Okay, so we used the mnemonic in class, SOHCAHTOA. Sine is opposite over hypotenuse. Right? So SOH, so sine is opposite over hypotenuse. Across from theta is the opposite side. Across from the right angle is the hypotenuse. Cosine theta. In class, we also talked a little bit about functions, and we talked about how you could have similar triangles and how the ratio is still going to be the same. And so we talked a little bit more in depth in class, but I'm not going to make a video for that as well, because most people were paying attention to that anyways. All right, so here we have cosine. Okay, so we want to do cosine of theta. Okay, cosine of theta is going to equal adjacent over hypotenuse. So we input an angle measure. And we're going to get a ratio. That ratio is going to be the adjacent side over the hypotenuse. Okay. So we're inputting an angle measure, and they're giving us the adjacent. So theta has two adjacent sides. It has the hypotenuse and the adjacent leg. What we're really talking about is the adjacent leg. So we're leaving the hypotenuse out of this, and we say opposite over adjacent, opposite or adjacent. We're talking about opposite across from the leg that's across from the angle, and the adjacent side is really the adjacent leg of the triangle. Right? We have two legs and a hypotenuse. Right, and then tangent is equal to. Okay, so tangent of theta. Again, tangent is a function. Okay, you input an angle measure, it's going to give you a ratio. That ratio is going to be the length of the opposite side over the length of the adjacent side. So opposite over adjacent. Okay. Opposite over adjacent. Okay. So SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is, well, let's write it down. So somewhere on the top. And so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay. And example 1. Okay, you want to put each ratio in its simplest form. So I believe on your sheet the numbers were ABC. And we have 3, 4, and 5. Yes. All right. So sine of A. So sine is opposite over hypotenuse. So if we're looking at A, here's angle A. We want the ratio. So here's angle A. So sine is opposite over hypotenuse. So we want the opposite side. So we want to cross from angle A. The side across from angle A is CB, which is 4. And the hypotenuse is across from the right angle. So our hypotenuse is 5. So we have 4 over 5. Then we have sine B. Okay, so angle B is down there. Sine is opposite over hypotenuse, so we want the side across from B, which is 3. Okay, and then we want the hypotenuse, which is 5. 3 over 5. Cosine of A, so we want to look at angle A. Cosine is adjacent over hypotenuse, so we want to look for the adjacent leg. Adjacent meaning next to. So angle A is next to 3 and 5, but we want the adjacent leg, which is just 3. Okay, and then the hypotenuse is 5. So adjacent side over the hypotenuse. The length of the adjacent side over the length of the hypotenuse. Cosine of B, so here's angle B. Cosine is adjacent side, the adjacent leg over the hypotenuse. So again, here's our two legs. Here's the hypotenuse. So the adjacent leg is 4. The hypotenuse is 5. Tangent of A. So we want to look at A. Tangent is opposite over adjacent. So opposite is 4. Adjacent is 3. Tangent of B, so again, opposite over adjacent, so opposite across from B is 3. Okay, and then the adjacent leg is 4. That's example 1. Example 2. Example 2, we have the sine of 30 degrees. Okay, we have the sine of 30 degrees. Let me fill in the missing pieces here. We have A, B, C. Yeah, 30, 60, 1, 2, square root of 3, square root of 2, C, C, B. I think there were two different versions of this because, and here this looks like the 30, 60, 90, and that looks like the 45, 45, 90, but on the one I gave you, the top one looks like the 30, 60, 90. So for some reason, I think there were like two different versions and they had them flipped. Anyways, we're just going to go with what we have. Pretend this is the 45, 45, 90, because that's what's on your paper. The bottom one was the 45, 45, 90. The top was the 30, 60, 90. Sine of 30, it's going to equal, so sine is opposite over hypotenuse. Here's our 30-degree angle. So that's going to equal 1 over 2. Cross from 30 is 1. Hypotenuse is 2. Okay, sine of 45. So sine is opposite over hypotenuse. So here's 45. You can use either one. Across from 45 is 1. And the hypotenuse is square root of 2. And if we use the other one, across from this 45 is a 1. And the square root of 2 is still the hypotenuse. We want to rationalize the denominator. Okay, so how do we rationalize the denominator? We multiply by square root of 2 over the square root of 2. And that's going to give us square root of 2 over square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. So square root of 2 over 2. Cosine of 60. So cosine is adjacent over hypotenuse. So here's 60. The adjacent side, so the leg adjacent to 60 degrees is 1. And the hypotenuse is 2. Cosine of 45. So cosine of 45. So the adjacent side is 1, and the hypotenuse is square root of 2. Again, we need to rationalize the denominator, so same as B. Okay, we're going to get square root of 2 over square root of 2 over 2. Tangent of 30. So we go to 30. Tangent is opposite over adjacent. So opposite of 30 is 1. Adjacent is square root of 3. Okay, so we got to rationalize our denominator. So that's going to be square root of 3 over the square root of 3. Okay, this becomes square root of 3. Square root of 3 times square root of 3 is the square root of 9. The square root of 9 is 3. So we have square root of 3 over 3. Tangent of 60. So here's our 60-degree angle. Tangent is opposite over adjacent. So opposite of The 60-degree angle is square root of 3. And adjacent is 1, so that's just going to be the square root of 3. Okay, then tangent of 45, opposite over adjacent, 1 over 1. If you use the other 45-degree angle, you get the same thing. Opposite of 45 is 1, adjacent is 1. So 1 over 1, which equals 1. Example 3, we are going to use the calculator. Okay, use the calculator. So we want to hit the trig button on the calculator. If we can, I don't know if I should pull the calculator up on the. So let me just rewrite it here. That's sine of 20, cosine of 70, and tangent 33. Okay, then we pull out the calculator on the computer. Right, so what we want to go to is you want to hit the trig button right here. Next to the equal sign, you hit trig. We want to do sine. Okay, and then we simply put in sine of 20. We hit enter, and we get 0.34202. The question asked us to round to the nearest hundredths place. So we have the tens place and then the hundredth place. So we want to put our answer as 0.34. And the second one, we want to go to cosine of 70. Hit enter, and again we get 0.34202. So we want to round to the hundredths place. So that's going to be 0.34. And the last one, we have tangent of 33. We hit enter, and we get 0.649408. Okay, and we want to round to the hundredths place, so we're going to have, again, if we were rounding, we're going to get 0.34, 0.34, and 0.65. Okay, so that's going to be our three answers here. Okay. Example 4. Example 4. Solve sine of 40 equals x over 18. Okay, so we have sine 40 equals x over 18. Well, how do we get x by itself? We have to multiply both sides by 18. Okay, these 18s cancel. We get 18 times the sine of 40 equals x. From there, we simply put it in the calculator. So we go to that trig button. Okay, we take the sine of 40. And we multiply, and that's going to give us 0.642788. And we simply multiply that by 18. And we get 11.57. Example 5. Okay, we have cosine of 52 equals 19 over x. So we want to multiply both sides by, we want to get x by itself. Okay, we want to solve for x. So we're going to multiply, we want to get x out of the denominator then. So we want to multiply both sides by x. So we have x cosine of 52 equals 19. Divide by cosine of 52. Cosine of 52. We get x equals 19 over the cosine of 52. If we put that in our calculator, we put in 19. We hit the divide sign, and then we put in trig cosine 52. We hit enter. We get 30.8. 30.86. Cosine of 52 is 0.615661. We have to do 19 divided by that answer, and we get 30.86. Example 6. Okay, example 6. All right, we have tangent 29 equals x over 112. To get rid of the 112, we multiply both sides by 112. So we get 112 times tangent of 29 equals x. So tangent of 29, 29, not 28, 29 is 0.554309. We want to multiply that by 112. We get 62.0. 62.08 equals x. Okay, so point, there's a decimal. If it'll come up. Okay. 2 more examples. Example 7. It's going to be up. Example 7. These are the types of problems we really want to be able to solve. Okay, we are given 25. So the first thing we should do, or I want to do, is I want to identify the sides of the triangle relative to the 25-degree angle. Okay, so this is the AC is the hypotenuse. Okay, if we're talking about the 25 degrees, then we know AB is the opposite side, the opposite leg, because it's across from the 25-degree angle, whereas the 5.1 is adjacent because it's right next to it. So this is our adjacent. Adjacent, opposite hypotenuse, relative to the 25-degree angle. Okay, if we were talking about angle A, then this would be the opposite side, and this would be the adjacent side. All right, so now we have sine of theta is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, we have to figure out which one we want to use. So the first question wants us to find AB. I'm going to call AB x. So we want to find x. We want to find x. It represents the length of AB. Well, x is on the opposite side. Okay, so we want an opposite in our equation. So that eliminates cosine, because cosine of theta is adjacent over hypotenuse. So we can't use cosine to find x. Right? And then that leaves us with sine, which is opposite over hypotenuse, and tangent, which is opposite over adjacent. If we did sine, we would have x over blank. Right? We don't know what AC is, so that's not going to help us solve. So we want to use tangent, right? Because we have the opposite side, or we're trying to find the opposite side, and we have the adjacent side. So our combination here is opposite and adjacent, and the only one with both opposite and adjacent is tangent. So we have the tangent of 25 is going to equal opposite over adjacent. That's x over 5.1. We then need to solve for x, so we have to multiply both sides by 5.1 and 5.1. Okay, these cancel. We get 5.1 times the tangent of 25 equals x. We put in the calculator, we have 5.1 multiplied by, we hit the trig button 3 times to get the tangent of 25. We hit enter and we get 2.38. Round up, 2.38 equals x. Can we see those decimals? Because I can hardly see the decimals. There we go, 2.38. Okay, that gives us AB, 2.38. Now we need to find AC. So I'm going to call AC. Well, I'm going to erase all this. So let me erase all this so we have more room. Okay, so this is 2.38. We now have 5.1. Okay, we want to find AC. AC is our hypotenuse. Let's call that Y. So let's call it Y. two different ways we can do it. But first of all, we're trying to find y. So we're trying to find the hypotenuse. So that immediately eliminates tangent. Right? We're trying to figure out which equation we want to use. It eliminates tangent because tangent is opposite over adjacent. So there's no way we'd be able to solve for y if it's not even part of the equation. Okay. From there, we can either use sine or cosine. So sine of 25 is going to be equal to the opposite, which is we found to be 2.38 over the hypotenuse, or we can do cosine of 25 is adjacent, so 5.1 over y. Either way is going to work for us. Let's just do it the first way with sine, because I have it written first. Okay. Multiply both sides by y. Okay, the y's on this side are going to cancel. We get y times sine 25 equals 2.38. Okay, we divide both sides by the sine of 25. Sine 25, and we get y equals, let's see, 2.38 divided by the sine of 25 is going to give us 5.63. Okay. There can be a rounding issue because this really wasn't just 2.38, it was 2.37817. So let's try that. If we did 2.37817 divided by the sine of 25, we're going to get 5.627, which is still rounded up to 5.63. So they can be a little different depending on how you round, but AC is going to be 5.63. Okay, 2.38 squared plus 5.1 squared should equal 5.63 squared by the Pythagorean theorem. We don't need to put it in, but that's what should work. All right, last one, example 8. Okay, it's saying find each length and round to the nearest hundredth place. Hundredth place again is 2 decimals. You have the tens place and then the hundredths place. Okay, here we have 50 degrees. So let's label. We have the opposite side over here. It's a leg, right? We have the right angle. So it's the leg across from 50 degrees. This is our hypotenuse. Okay, it's across from the right angle. And then the leg that's adjacent or next to the 50-degree angle is DE. Right, so I'm going to call the hypotenuse X and the adjacent side Y. Okay, first question, find the F. So dF we called X. Okay, you put any variable you want there, but I called it X. You could leave it as dF. I just want to be as least confusing as possible. Okay, so sine, well, we have to figure out which function we want to use. Okay, we want to find the hypotenuse, so we should have hypotenuse in the equation. So that eliminates tangent. Okay, we also know we have 4, which is the opposite side. So we want to use the one that has the opposite side as well. So which has opposite and hypotenuse, that's going to be the sine function. So we're going to do sine of 50 equals opposite over hypotenuse, so 4 over x. We want to solve for x, so we multiply both sides by x. So we get x times the sine of 20, or the sine of 50, I'm sorry, equals 4. And we want to divide by the sine of 50. So we get x equals 4 divided by the sine of 50. Is 5.22. I remember that one, 5.22. Okay, and then we now have 2 of the sides. We want to find the third side, so we want to find DE. That's the next question. I labeled that Y. All right, I'm going to erase this so I have room to write. Again, now we have 2 different equations we can set up. Really 4, but 2. Okay. We want to find y, which is adjacent to the 50 degrees. Right, so it better have adjacent in it. That means we can eliminate sine. So we can either use cosine or tangent. If we use cosine of 50, that's going to be adjacent over hypotenuse. So that's y over the hypotenuse, which we just found to be 5.22. Okay, we can multiply both sides by 5.22. Okay, and we get y equal, these cancel out, and we get y equals 5.22 times cosine 50. We get 3.36. Round up to 3.36. Okay, the other way we could have done it, if we did tangent, we could have done, so tangent of 50, okay, equals opposite over adjacent, so that would equal 4 over what would have been y. Okay, and then we could have solved for y. We could have multiplied both sides by y. Right, and then we could have divided by the tangent of 50. Divided by the tangent of 50, and we would have gotten y equals 4 divided by tan 50, which is 3.36. Okay, which is exactly what we got over here. Okay, we could have also found the other angle. This angle would have been 40 degrees, right? Because the three angles have to add up to 180. And then we could have done sine or tangent using the 40-degree angle instead of the 50-degree angle, but that's fine. All right. So those are the notes we did in class on Tuesday and Wednesday.